we have the integral from x squared plus 1 over x squared plus 1 dx. Awesome. Good. Which function prime is x squared? We know it's x to the third over 3 plus. Which function prime is 1? We know it's x plus. Now we know which function prime is this. There's only one function that we differentiate and we get this.
This is sine hx.
Careful. Okay, so our tangent prime is 1 over x squared plus 1. Please remember that. It's a very important function. Okay. Final section. I promise no more new material after this. So I'm on 11, yes. So 5.5. The substitution rule. There are a lot more techniques of integration in Calc 2. So what techniques we know from here? Simple. What do I mean by simple? I'm able to find the antiderivative. The antiderivative of this is this. The antiderivative of this is this. The antiderivative. So that's simple. Nothing sophisticated. Maybe a distribution here or nothing really. Simple. What is the second method we are going to look at? Is this one. Substitution. So these are techniques techniques of integration. I'm trying to always write uppercase so everyone understands what I'm writing. And sometimes it doesn't come very easy. Sorry about that. Okay, so what does a substitution do? A substitution makes it easier. To integrate. If it doesn't make it easier, then the substitution is not the right one. Or maybe a substitution doesn't work, or maybe something else, other techniques have to be applied. But for now, we're going to look at examples that are easy of definite and indefinite integrals that are easy to determine or find using a simple substitution. Okay. And you'll see how this works. We're going to start with indefinite integrals using the substitution rule. Yes, here they are giving us the substitution, so I'm just going to start with something like 12, and then I'll let you choose anything you want. So we have the integral from sine t, the square of 1 plus cosine t dt. Before we even attempt to find the substitution here, we have to refresh our memory on, note, we've done this before, well, let's do it again. Derivative and differential. It's a big difference. So give us a function, any function you want. Can anyone make up a function?
2x plus 1.
Awesome. Can anyone give us f prime of x? And remember the differential is denoted by dy. So for this function, can anyone give us the derivative? And for the same function, can anyone give us, because this is the same with y, of course. Can anyone give us the differential?
Is it 2 and 2dx?
Awesome, brilliant, thank you very much. So please understand that this is crucial difference. So when I'm asked to find the derivative for this function, I will only write 2. When I'm asked to find the differential for f, I have to write the formula of f prime of x dx. So this is the differential of the given function. Good. So I'm going to copy this integral again. You don't have to do it, but I need to. So the integral from sine t, the square root of 1 plus cosine t dt. I'm going to show you the method that I like to present for very simple integrals like this one, but I can also show you something else. If you like it, use the method you like. It doesn't matter to me. So here's my thinking process. I look at this integral, I see it's a function times another function. I look at this one, I say, oh, what can I do to sine? Nothing. Okay, so I'm going to look now at this. And this is a square root of like a plus b, which cannot be simplified. Not simplifiable. This is a problem. If I have the square root of a times b, it's a different story because I can write this, so who knows, maybe I can simplify. But this is addition or subtraction. So this is my starting point. I look at this and say, I think that I would be in better shape if I say, let any letter but t, let u be 1 plus cosine t. So notice that I created a function and I want its dy. And you can say, what do you mean you want its dy? Well, when I move from this integral to something else containing u, I have to have du. So if the function has t in it, the integral has to have dt. If the function has u in it, the integral has to have du. So that's why from here, I need to find the differential of this function. Can anyone tell us what is the differential of u? U being the function 1 plus cosine t.
Negative sine t dt.
Awesome. Negative. Okay, I'm sorry. So indeed, negative sine t dt. So let's see what we have. We go back. I have this piece. I have this piece, but I don't have negative. What do I do? Nothing. Multiply by negative twice. This is still 1. But now I have all 3 pieces. I have the negative 1, I have the sine t, and I have dt. So this and this and this will form the du, which is here already. All I have to write is the square root of u. And that minus left over. Because this was already incorporated in du. Negative sine dt. Negative 1 sine t dt is right here. Notice that once I move from the integral in t, there is no t in the new integral. I changed everything from t to the corresponding u. Now, how do I address this? Very easily. I have u to 1/2 du, which is negative u to 1/2 plus 1 over 1/2 plus 1 plus a constant c. Of course, I will flip and write negative 2/3. U has to give back 1 plus cosine t to 3/2 plus a constant c. Since the integral was given in t, the final answer has to be given in t as well. So the substitution helped us till this point, but now we don't need it anymore. We go back and put in the original function in. Now you can say, I don't really like to create, this is the easiest thing, but you can say, I don't really like to create the negative. Fine. Then solve this for dt. So dt equals du over negative sine t, but be careful, you cannot have t and u in the same integral. So a number or a sign can be easily be made up. -1 times -1 is still 1. I didn't change anything. However, this negative goes with sine and dt, and this negative has to stay. You can say now, I don't trust this. Show me. I don't believe this. Very easy. All we have to do is differentiate. And I have to show that I get the original function, sine t, the square root of 1 plus cosine t. So let's do that. Okay. So -2/3, bring down 3/2 times the inner function to 3/2 minus 1, which is 1/2, times the inner function prime, which is negative sine t. These two go away. The negative sine t with a negative will create the sine t, and 1 plus cosine t to 1/2 is the square root of 1 plus cosine t. So remember, for the indefinite integral, no matter what you have, you don't need anyone to tell you whether this is correct. Just differentiate it and see if you get the original function. If you don't get the original function, then this is wrong. And we use the substitution rule. The floor is open for any problem. Still, for the indefinite, there is a minor difference for the definite. Anything you want to choose. Anything.
Can we do number 20?
Yes, number 20. So in 20, we have the integral from e to -5r dr. Awesome. Okay, e to something is friendly. That's friendly. But I don't like that power. It's not, it's a function, it's not plain x. So I will say, let y be -5r. Any letter, it doesn't matter. As long as I can determine dy. What is dy?
-5 dr.
Excellent. And you can say, oh, what do I do now? A constant, or factor, no problem. Never. Okay, so I'm going to multiply by -5 and divide by -5, which is 1. I didn't do anything. If I multiply the numerator by -5 and the denominator by -5, this is 1. But now, this with this will give us dy. -1/5 in front. This with this is dy, and this is e to y. And then -1/5 e to y plus a constant c. All I have to do is just plug it back in. And you can say, I don't believe this. Very easy. Let's differentiate. -1/5 e to -5r prime will be -5, which will eliminate this, to e to -5r. And constant plus times constant prime is 0. Very good. I would like to look at 22. In 22, we have the integral from sine 1 over x squared dx. Perfect. Can anyone guess a substitution? It's okay if you're wrong, because if it's difficult to determine the x, the y or t, whatever, then you know you're on the wrong track, and you'll go back and try another substitution. Come up with something else. What do you think bothers me here? So to speak, of course.
Is it sine 1 over x?
Exactly. This is what bothers me. I like this. I don't like this. Because this is already a function inside sine. This is okay. This is not okay. So then what will be my substitution? Any letter you want. Let's say T. What do you think?
Sine 1 over x?
No?
1 over x?
Yes, of course. Can anyone give us dt? Anyone else but Victoria? She already gave us all the dt's and dy's and dz's and... Can anyone differentiate this and give us dt? Anyone?
Negative 1 over x squared.
Dx.
Awesome. So let's see, do we have this here? Of course. Here it is. Dx 1 over x squared and the negative. So then I have to copy 1 minus, and the integral becomes sine t and -1 over x squared and dx. All these three pieces are dt. And now it's nice because I can already put plus because I have cosine t plus a constant c. All I have to do is just write cosine 1 over x plus a constant c. And you can say, show me. Show me that when you differentiate this, you get that function, sine 1 over x squared. Sure. It will take a blink to convince you of that. So cosine 1 over x plus a constant c prime. Cosine function prime is negative sine 1 over x times the inner function prime plus the constant prime, which is 0. So the negative with the negative will go away, and I have sine 1 over x squared. Sine 1 over x squared. And we used the substitution t equals 1 over x. So let's look at anything else, or we continue with the last topic, which is the substitution rule for definite integrals.